Now, how can we convert large number of variables into independent dimensional numbers? For that, we must understand what do we mean by dimensions. We know that every physical quantity like velocity, acceleration, viscosity, force, these are written in terms of some dimensions or fundamental dimensions. What do we mean by fundamental dimensions? Like mass, length, time, temperature, light intensity, etc. These are fundamental dimensions required to describe any physical quantity, right. Like how do we write dimension for acceleration? How do we write dimension for acceleration? We know acceleration is equal to velocity divided by time. So, it is the dimension of velocity divided by dimension of time. What is dimension of velocity? It is length divided by time and divided by dimension of time. So, it is again time 1 over time, this may be written as L over t square. So, dimension of acceleration is written as length divided by t square. Similarly, how do we get dimension for viscosity? This can be done with the help of Newton's viscosity law. As per Newton's viscosity law, we have studied in very first chapter that tau is equal to mu du over dy. This law is valid for Newtonian fluid, right. So, if we want to know what is the dimension of mu, we have to analyze this equation. So, this equation may be written as mu is equal to tau divided by du over dy. What is tau? Tau is shear stress. So, what is shear stress? Shear stress is equal to force divided by area. What is the dimension of force? It is mass into acceleration, right. So, its dimension will be m into acceleration. For acceleration, we have already learned what are the dimensions, L t minus 2. So, this is the dimension of force, and what is the dimension of tau? Shear stress. So, divided by area, divided by area. What is the dimension of area? L into L, L square. So, this may will become m L minus 1 t minus 2. So, what is the dimension of tau? It is m L minus 1 t minus 2. What is the dimension of u? It is du means u, and what is the dimension of dy? Means it is having dimension of distance. So, du means L over t and dy means L only. So, with the help of this analysis, we can find out the dimension of mu, which is equal to m L minus 1 t minus 1. So, similarly, we can get the dimension of any physical quantity in terms of fundamental units. So, physical quantity like mass is having dimension m, length is having dimension L, time is having dimension t, temperature theta, velocity L over t, angular velocity means radian per second. So, time t minus 1, acceleration L t minus 2, etc., etc. So, all physical quantities are having some kind of fundamental dimensions, right. Here we have dimension of different physical quantity. So, for doing the dimensional analysis, we must know the dimension of that physical quantity which is involved in that physical phenomena.